that stuff we did yesterday, which you told me you understood, you didn't have any difficulty in the homework factoring those various functions. I asked the question and nobody said they had any trouble with it. So let's talk about how we can use that to solve a polynomial equation. There are other ways of solving polynomial equations. We can graph them, and we're going to talk about how graphs can help us to solve them. But what if you didn't have a graph? What if you didn't have Desmos, right? What if you didn't have some fancy calculator that had a way of solving polynomial equations on it? What do you do? Well, I'll tell you what you do. You try to do what you do with quadratic functions. You try to factor it. And once you factor it and set it equal to 0, use the zero product law, and you have your solutions. Okay, so let me just fold over my little tablet here and get started. So what I'm asking us to do is to solve a polynomial equation that looks like this, right? And I'm thinking, okay, you said to factor it. How exactly would I be able to factor this? Just move this up a bit here. Oh, that moved up too far. That always happens. Okay, there we go. How can we factor this? That's the question I need to ask. Well, Noah was right off the mark where he says that, oh, sorry. Let me just try to erase this here. He says that we can factor out a common factor of x. And he's absolutely right. If you look at that expression, and this was one of the questions on your homework as well, right? There was a common factor of x right at the beginning. So if there's a common factor of x, why don't I go ahead and factor that out? So I'm going to go ahead and say, okay, x, and when I divide all of these by x, I'm going to get x squared minus x minus 2 equals 0. That's a good start. And Noah made a very good observation. He says, then it's quadratic. So that means that I can factor it like a regular quadratic, right? This is going back to grade 10 now. So I still have that x on the outside, but now I have 2 more brackets, and this is not hard to do, right? I know that I'm looking for 2 numbers that multiply to give me minus 2 and add up to give me minus 1. So I'm thinking, how about x minus 2 and x plus 1? That should work, right? Because when I multiply those 2 numbers together, I get minus 2. When I add them up, I get minus 1. Okay, so we factored it. That's great. But where do we go next when we factor it? What does exactly the zero product law help us to do when we have factored something and everything is equal to 0? Well, here's what the zero product law says. I write this on the side. Excuse me. The zero product law. The zero product law says, and by the way, I notice that not everybody has joined me on the board, and that's fine for now, but at some point you need to be on the board, because when you start working on your assignment, I'm going to be looking to see that everybody is here. Okay, so please make sure that you join me on the board. Even though you might be looking at my presentation now, you do need to join the board at some point. Okay, so zero product law says this. If I'm multiplying these 3 things, there are 3 things being multiplied here, right? I'll just put a little thing on them. So I'm multiplying this, I'm multiplying this, and I'm multiplying this, those 3 things. Then what the zero product law says is that one of those 3 things has to be 0. For you to get 0, then one of those 3 things has to be 0. So either, and I'll put it this way, either the x is equal to 0, or the x minus 2 is equal to 0, or the x plus 1 is equal to 0. That's the only way to get 0 when you multiply 3 things. If one of those things is 0, or they're all 0. So the first one is already solved. X equals 0 is an answer. We're done. The second one just needs a little bit of work, which is where we just simply add 2 to the 2 sides. Okay, so the first solution is already done, right? X is equal to 0 is one answer. Done. The second one, of course, I just have to do a little bit of work, which is to bring that 2 onto the other side. So x is just equal to 2. And the third one is x is obviously equal to minus 1. That's a very simple way of moving things around with algebra. So we right now have three solutions, right? So if I go back up to this question, right, x cubed minus x squared minus 2x equals 0, and I was asked to solve this equation, I have all three solutions. X equals 0, that's 1, x equals 2, and x equals minus 1. Those are my three solutions for this polynomial equation. All right, let me just let that sink in for a second. Isaac, how do you feel? Does that sound about right to you? Just checking in with the room here. Isaac? Sounds good. Okay, perfect. All right, so that's number one. Okay, that's just a warm up there. That just sort of gets us going on what we're doing. And we're going to move on to board number 2 now. So on board number 2, I have another cubic function. And not all going to be cubic, by the way, just FYI. One of the questions I'm going to be asking you for is not necessarily cubic. And I'm thinking, okay, there is no common factor of x this time. So I can't factor out a common factor of x. Now, let me see if I can just move this up a bit here. That always seems to happen when I try to move it up. Let's see if I can move it back down a bit. There we go. Okay. So what do you think, folks? I can't factor out, remember the first one, I factored out a common factor of x. Look at what Noah just said. Noah said grouping. Now, why does Noah think that grouping is going to work? Not Noah this time, not Noah. But Noah says grouping. Is he right? Can we actually group this one and factor it like we did yesterday? The homework was all about grouping. The way that you know that it can be factored by grouping, multiply that 3 in the front, right? Let me show you again, because we talked about this yesterday. Multiply this 3 in the front by the minus 4. Then multiply the minus 12 with what's in front of the x squared term. If that product, which is the 3 and the minus 4, is the same as the minus 12 times the 1, if that product is the same, then it means that you can factor by grouping. So try to remember that from yesterday, right? That's how you know you can factor by grouping. That always works. So in this case, it's 3 times minus 4. So I'm just going to show you what I mean. So 3 times minus 4, which is the same thing as 1 times minus 12. Right? That's your rock solid way of verifying that you can factor by grouping. So that's exactly what we're going to do right now. We're going to factor by grouping. Right? Let me just erase all of that with the new technique I learned from that video. So everybody remembers that from yesterday, hopefully. So we're going to go ahead and factor by grouping now. The common factor between the first two terms would be the x squared. Okay, hope everybody agrees with me on that. That's the common factor between the first two terms. Then I'm going to factor that out. That's going to give me 3x plus 1. Everybody with me so far? Everybody okay with that so far? Let me check in and see if everybody's okay with that. Joel, how about you? Does that make sense? Are you good with that so far, Joel? The first thing I just did there? Where's Joel at? Joel, okay, good. Then we're going to factor out of the next two terms. Can somebody help me out with what the factors are of the next two terms? Kayla, go ahead, please. Okay, what I was saying before is that the way that you know that this can be factored by grouping, and thanks for the question, by the way, is when, and I'll circle them again, is when you multiply this number. Oh, sorry, I forgot to click on the, geez, hold on a second. Let me just undo that. Undo. All right, is when you multiply this number by the constant, so the coefficient of the x cubed term, which is the first part of what I did, right? It's equal to the product of this coefficient and this coefficient. So that's what I was talking about before. Kayla, does that help you out? You're welcome. And that's the proof positive right there. That tells you that you can factor by grouping. Okay, so let me just get rid of that. And let's get back to what we're doing. So common factors. You were asking about common factors. What would the other common factors be? No. So Keonte is saying that minus 4 is a common factor, and I agree. So let's put that -4 there, or it's in blue. Doesn't really matter though. I'll change back in a minute. When I factor out that -4, it looks like I'm getting a positive 3x and a positive 1. And that's all still equal to 0, by the way. So that hasn't changed. Let's see if I can just quickly get rid of this stuff here. Okay. So then, of course, we know, is Neil with us now yet? Has Neil decided to join us back now? Is Neil here? Where is Neil? Neil's still not here. Okay, so we still have another common factor between both of these of the 3x plus 1. So I'm going to say that 3x plus 1 in one bracket, and then what's left over is the x squared minus 4 in the other, equals 0. But you know, we still haven't yet solved this equation because we haven't fully factored the function. That x squared minus 4, you all know, can be factored again because it's what we call a difference of squares. So the 3x plus 1 is still there. But then we're going to say x plus 2 and x minus 2. All of that equal to 0. All right. So far, are we good? Is that making sense? Riddy, how about you? Sharisa, Riddy, are we both on track with this so far? Sharisa and Riddy? Sorry, Riddy, I got Riddy. Where's Sharisa? Great. Okay. Neil, still looking for Neil. Still looking for Neil. Where's Neil? Okay, so now we have these three things being multiplied equal to 0. Okay, so we're going to do the same thing again. We're going to set each of these three things equal to 0. So 3x plus 1 is equal to 0. X plus 2 is equal to 0. And x minus 2 is equal to 0. Went to the bathroom. Yes, I did call you, Neil. And if you are going to leave, you got to let me know, right? Because I'm expecting that people are going to be in class listening and paying attention. So if you say you want to hall pass or something, that's fine. But you really need to sort of be on track every time I call out to anybody. Okay? Thank you very much. Let's keep going. Well, this is not hard to solve. We know that if I do all the math on that, that x is therefore equal to minus 1 over 3. And x is equal to minus 2, and x is equal to plus 2. Okay? Yes, you do. Just you know, not just for Neil, but for everybody else. If you have to leave the it's just like if you're in a regular classroom, no different. So anyway, so those are my three solutions, right? So again, I was trying to solve a polynomial equation. Turns out that we had a shortcut this time, that we didn't need to go through that process that we did yesterday. Well, we did learn about factoring by grouping yesterday anyway, but sometimes we have to do more, which some of the questions will require. But for this one, it's so much easier if we can factor by grouping to do that. So we could, so we did. And here's our answer. Minus a third, minus 2, and plus 2. What about the zero product law? Noah, this is a zero product law. The zero product law says we're multiplying three things. Let me underline the three things we're multiplying, right? So we're multiplying this, and this, and the result is 0. What that tells us is that one of those three things I just multiplied must be 0 for me to get 0. That's what the zero product law is all about. Zero product law doesn't say that one of them excuse me, one answer is 0. That's not what the zero product law says. What the zero product law says is that one of the three things is equal to 0. So the three things that I'm multiplying 3x plus 1, I'm multiplying x plus 2, I'm multiplying x minus 2. Well, one of those things themselves must be equal to 0 for the product to be 0. Does that make sense, Noah? It doesn't mean that the answer is that x is 0. Zero product law says that one of the things that you're, so which one is it? So which one is it? Okay. All right, let me sort of go over that because I'm glad you're stopping me and I'm trying to get clarification on that. Zero product law says this. If I want to get 0 by multiplying some things, one of those things has to be 0. You cannot get a product of 0 without one of the things that you're multiplying being 0. That's just not possible, right? One of them has to be 0. So if I'm multiplying the 3x plus 1, which I've just underlined, and I'm going to point to it right now, if I'm multiplying this, and my answer is 0, then either the 3x plus 1 is equal to 0, the x plus 2 is equal to 0, or the x minus 2 is equal. That's what the zero product law says. It says that one of these things must be 0 for me to get 0 at the end. So I take each one of them and set them equal to 0. I took the 3x plus 1, I set it equal to 0 down here. Then I solved it. I took the x plus 2, set that equal to 0, and I solved it. Took the x minus 2, set that equal to 0, and I solved it. So when we had the one before, let me take you back to the question before this. We use the zero product law here as well. There were 3 things being multiplied together to give us 0. One of them was just simply x. So if it's just x, it means that that x itself, it has to be 0 for the result to be 0. Also, the x minus 2 could be 0, or the x plus 1 could be 0. But one of them is just simply that x itself has to be 0. You see what I'm saying, Noah? Does that make sense to you now? Okay, perfect. Okay, so let's go back now and we finished this question. Those are my 3 solutions, minus 1/3, minus 2, and plus 2. By the way, as with any other equation that you've done since you've been in high school and solving equations, you should know that plugging any of these solutions back into the left-hand side of this should make the left-hand side equal to the right-hand side, right? So if I wanted to check my answer, I'd put that, for instance, that 2 into this equation, and I should end up with 0, since that's the left-hand side and the right-hand side is 0. Just FYI. I always like to check things when I was a student just to make sure I got everything right. I'm not saying I got everything right. Let me just be straight up with you. I got stuff wrong as a student too. One of the ways I reduced the possibility of getting stuff wrong, was I did a check at the end. Is my answer reasonable? Does it make sense? Does it fit into what was given to me at the beginning? Okay, let's move on. How about this guy? Here's the thing. Let me see if I can move this up a bit here. I know sometimes it makes me lose the question. Let me see if I can bring it back down now. Yeah, that's one of the things I don't really like about the board, but you know, it's a minor inconvenience. Okay, so now I have it where I want it. 2x cubed plus 3x squared minus 11x minus 6. That's what we have to solve. Unfortunately, I cannot factor by grouping. How do I know that? Because I take that first number, which is the coefficient of the, oh, I forgot to change the color. Now, why did I do that? Let me fix that. I took that first number and I multiplied it by the last number, and I got minus 12. Unfortunately, when I multiply the 2 middle numbers together, I don't get minus 12. So that's unfortunately not going to help me this time. So let me erase this and think, okay, that didn't work out. So where do I go now? Is the question. Know that didn't work out. What do we do now? What did we do yesterday when we had to factor? Right? And that's really factor theorem. Thank you, Noah. And how do we apply the factor theorem again? What's that first step that we have to take to use this factor theorem? Right? Not just Noah. I don't want everybody to be depending on Noah for everything. So I want to get everybody to pitch in a little bit, right? What would be the thing that would make sense for us to do as our first step if we're going to use this factor theorem? Find factors of minus 6. Thank you, Harish. Factors of the last constant. Perfect. So one of the numbers that will always be a candidate is 1. Okay? Because 1 is a factor of everything. And if you're lucky, the 1 will work. So let's try it and see what happens with the 1. So I'm going to plug 1 into this and see if we're lucky. So it's going to be 2 times 1 cubed plus 3 times 1 squared minus 11 times 1 minus 6. All right, so let's see if we're lucky now. Is this going to, and of course, the result of this should be equal to 0 if this is going to work. So this is putting 1 in everywhere we had an x. So this is 2, this is plus 3, this is minus 11, This is minus 6. Clearly, we're out of luck on 2. So where would I normally go with? I'd go with minus 1 instead. Minus 12, Joel. I thought you meant minus 1, right? Because I'm not going to go. That's not even a factor of minus 6. I'm sure you meant minus 1, right, Joel? No for the answer. Okay. All right. So, okay. Right. So that means that we're going to try minus 1 now. So everywhere I had a 1, I'm going to put a minus 1. So 2 times minus 1 cubed plus 3 times minus 1 squared minus 11 times minus 1 minus 6. And we're crossing our fingers and seeing what the answer. Oh, I see what you mean by the 12 now, the minus 12. You mean putting all of that together. I got you. I got you. Okay. So let's keep going now. So let's put it. Is that for the minus 1, by the way? No, I think I'm not sure what where the minus 2 is coming from for that. So you probably meant from this minus 17 plus. Yeah. Okay. I got you. I got you. Okay. Let's keep going now. So this would be minus 2, right? This would be plus 3. This would be plus 11. And this would be minus 6, if my math is right. And unfortunately, I think we're out of luck again because neither of those plus or minus 1 were, and that's just the nature of how this works. Sometimes it takes more than just plus and minus 1 for this to work, and that's not always the answer. And it doesn't seem to be the answer here because plugging in 1 did not work. Plugging in minus 1 did not work. So my next target would be 2. I'm going to erase all of this, right? And I'm going to try the 2. I need space, so I don't want to keep this here. Yes. Yeah, well, what's the minus 1 squared? That makes it positive, right? Did I make a mistake again, or are we good? That makes sense, right? Yeah, okay, good. Okay, Rachel, thank you. All right, so let's try this again. Let's try 2 now, positive 2 first, and just cross our fingers again. So 2 times 2 cubed plus 3 times 2 squared minus 11 times 2 minus 6. Actually, I'm going to erase all of this stuff here as well. Okay, let's go. Let's get all of that out of there. Clean up our board a little bit there. And get rid of this as well. Okay, we need the rule. Okay, so let's see what happens now. So 2 to the power 3 is 8 times 2 is 16. That's 4 times 3 is 12. This is minus 22 and minus 6. And I'm thinking, okay, 16 plus 12 is 28. I think we just hit the jackpot. I think the 2 actually works. What do you think, folks? Does 2 work for you? 2 seems to work for me. I think, yeah, Kristen, ready, Travis, thank you very much. This is equal to 0. So what does this mean again? If 2 works, what does that tell us if 2 works? What does the factor theorem tell us if when we plug in 2, we got 0, then we can conclude, yes, Jeremiah, go ahead, please. You're not saying it quite right. I know what you meant. X minus 2. There you go. So x minus 2 is a factor. That's what we're saying. So already we have one solution, just so you know. One of the solutions is 2, because 2 does make it equal to 0. But how do we get the rest of it? So that's where we're going to go next. And for me, I think that synthetic division is the faster way to do this. That's what I'm going to use, right? I'm going to go ahead and, oh, I don't need a third line down there, actually. Get rid of that third line. I think I need one more there. Along the top, well, on the side, I put the minus 2, just reminding you about that. So whatever you had as the factor, put the minus 2 there. And along the top, I'm going to put the 2, the 3, the minus 11, and the minus 6. And if I do all of this right, I should get a 0 on the end. I always put that 0. Thank you, Noah. You're right. Synthetic division is what I choose to go with. I put that 0 at the end because I'm expecting to get 0 if this in fact is a factor. Bring down the 2. Then I multiply minus 2 times 2, which is minus 4. So minus 4. 3 minus minus 4 is 7. 2 times minus 7 is minus 14. Minus 11 plus 14, of course, is 3. 2 times minus 3 is minus 6. And yes, it does match up quite well. So here's where we are so far. We have one factor of x minus 2. We're going to drop a degree and write the other factor. So now it's going to be, it was a cubic function before, so now it's 2x squared plus 7x plus 3. And all of that is equal to 0. That's where we are so far. All of that's equal to 0. Okay. So we need to factor this quadratic. And I showed you a method yesterday. Some of you like it, some of you don't, and I have no objection to using whatever works for you. I call it the magic X method. Well, I don't call it that, but it's called the magic X method. So I'm going to put at the top the product of the 2 and the 3, which is 6. And I'm going to put the 7 at the bottom, and I'm going to ask the question, what two numbers multiply to give me 6 and add to give me 7? Obviously, the answers are 6 and 1. Right? Multiply to give you 6, add to give you 7. Divide both numbers now by this coefficient right here that I'm pointing to, which is a 2, and reduce it down to its lowest terms. So reducing this down to its lowest terms would mean I'm left with 3 over 1. The other one cannot be reduced down, so I'm going to go back to black now. So what I have as my factor, so I still have the x minus 2. Oh, I thought I changed it back, but I didn't, obviously. So I can leave that bracket there in black. So what I have now is the same x minus 2, but now I have 1x plus 3, and I have 2x plus 1 equals 0. The magic X method is something that you either like or you don't, and I'm not trying to tell anybody what they should do as long as you end up with those factors. If you like decomposition or the straight line method or whatever else you want to use, as long as you're not cheating and trying to find some Google site that does that for you, then I'm good. So now we have 3 things being multiplied to give us 0. So one of them is x minus 2, so let's set that equal to 0 according to the zero product law. Let's take the x plus 3 and set that equal to 0. And then the 2x plus 1 and set that equal to 0. So I now have 3 solutions. X is equal to 2, which we knew before. X is equal to minus 3. And x is equal to minus 1 over 2. That's our third solution. So there you go, folks. 3 solutions. Many of these cubic functions have 3 solutions. Some of them have 2 solutions. We talked about this in the very first unit. Some of them have 1 solution. There's no cubic function that has no solutions. Just reminding you about that. Have to have at least 1 solution because of the end behavior. Either goes from 3 to 1 or from 2 to 4. So if you're setting it equal to 0, it has to cross the x-axis at some point. All right, so those are the 3 solutions that I have for this function. All right, I think we're coming along quite well here. Let's try another one. Well, this one is kind of weird because it's a little different from the others. How is it different? If I asked you for a difference, yes, Jeremiah, go. Mm-hmm. 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 Oh, okay. So we'll try that then. Let me move this up first. And I've learned that I have to do this twice. Bring it down. There we go. Okay. So from what Jeremiah is saying, we do want this thing to be equal to 0, because that we can't use a zero product law if it's not equal to 0, right? That's the zero product law by definition, needs everything to be equal to 0. So I'm going to rewrite this first by saying x cubed minus x squared plus 2x but minus 2 equals 0. Makes sense, doesn't it? All right. Let me do a quick check-in here. Nicholas, how about you? Are we making sense to you on this, Nicholas? Does that make sense? Where's Nicholas? All right. And how about Kristen? Kristen, does that sound about right to you as well? Perfect. So what do you think we need to do now, folks? Give me some ideas. Do we go ahead and start trying to find that first number? We can also do factor by grouping because the n numbers and the middle terms. Oh, look at you, Karis. Look at what Karis just said. One of the first things I want you to always do, especially if it's a trinomial, not a trinomial, sorry, a degree 3 function. What's the word I'm looking for here? Degree 3 is a cubic function. Especially if it's a cubic function with 4 terms. Always look to see if just possibly you can use factor by group. Because if you can, it's making it so much easier, right? Why go through the process of having to find that first one by trial and error and then use synthetic division and go through that whole thing if you can just factor it by factor by grouping? So I want to urge you to look for that option if it is there. Not always there, but if it is, makes your job a lot easier. So thank you, Karis. Can you also, not just Karis, but can you help me now to find the common factor between the first 2 terms? And everybody understands, by the way, I just want to be sure about this, that everybody understands why it is that Karis is saying that we can factor by grouping. Sheban, how about you? Does what Karis just said make sense to you? Sheban, are you there? Okay, good. Did you understand why Karis was saying we can factor by grouping? Did that make sense to you? Perfect. Okay, so we're going to try factor by grouping. Can somebody, not asking about the particular now, can somebody tell me what the common factor is of the first 2 terms? What's that common factor of the first 2 terms? There's an x cubed and a minus x squared. Thank you, Emily, x squared. So let's factor out that x squared. And it looks like I'm going to be left with x minus 1. All right, I make mistakes all the time, so please let me know if I make a mistake. And what is a common factor? Thank you, Sherbon. And what is a common 2? Okay, it's common factor of 2, so plus 2. If I factor that out, I'm going to get x minus 1 again. Okay, and that's still equal to 0. So it looks like I'm going to have in one bracket x squared minus 1 as my common factor. Second bracket is x squared plus 2 equals 0. Okay, good. Can we factor again? That's my next question. Is it possible for us to factor this again? So we always try to factor as much as we can. Emily says yes. Everybody agrees with Emily on this one? That we can factor again? Is it only Emily who's saying that, or do other people think that? So I get a no from Noah. I get a yes from Riddy, a no from Jeremiah. Okay, so there's lots of no's and yeses here. So you can't both be right. So who is right and who is wrong? Right? That's the question. There is a lot of no's and there are some yeses. There are some yeses and there are some no's. Who is winning the fight of the no-yes battle here? All right, Jeremiah, see your hand up. What do you want to tell us, Jeremiah? Mm-hmm. 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 Yeah. Okay. Good. I know since you can use a discriminant. I guess you could. That's one way to do it. But the fact is that, and you're right. You could use a discriminant to determine that. The discriminant in this case would actually be less than 0, which means that that's just not possible at all. So here's the thing. If it was x squared minus 2, then yeah, we couldn't factor it for x squared minus 2, not in a normal way, but we could end up with a solution. And I should probably mention that in a little while as to what that solution would be. But in this case, there is just nothing else you can do with this. So here's what this means. All right. And I'll show you why. And let me tell you why there's only one solution. Let's try this. Let's do this. Let's use that zero product law again. That I remember Noah was asking me about this. I have two things that I'm saying could be 0 for this to be equal to 0. One of them is x minus 1. The other one is x squared plus 2. Right? So, x minus 1 clearly means that x is equal to 1. I don't think anybody needs me to spend any more time on that. But how do you solve x squared plus 2 equals 0? Well, the first thing you might try is this. X squared is equal to minus 2. Right? Put that thing on the other side. And then you're going to say, okay, some of these I can solve this then, because you can maybe take the square root of two sides. Okay, so x is equal to the square root of minus 2, plus and minus, right? What's the problem here? Okay, Keontae, right? Problem here is that you can't take the square root of a negative number. Jeremiah, you had a comment. Go ahead. Or question. Yeah. You can't take the square root of a negative number. So this is undefined. Right? Now, there are some things called imaginary numbers, complex numbers. That's a whole branch of math. But for this course, we don't get into complex numbers. We don't talk about imaginary numbers. So really, there is only one what's called real solution. Jeremiah, please go ahead. Go ahead. Yes, the square root of minus 1. Yes. Yeah. Okay. So since we don't discuss imaginary numbers like the square root of minus 1, we can only have one solution from this, which is that x is equal to 1. That's it. That's all. That's done. Right? You don't have any more solutions. I said that cubic functions have at least one solution. Well, that's it. That's the only one. There are no more. Right? That's the whole one. That's the whole solution right there. So x squared plus 2 does not give us a solution. X minus 1 does, according to zero product law. And that's the end of that question. Okay. Are we still good so far? Travis, how about you? Still following along there with us? Is this all making sense to you, Travis? Travis, where's Travis at? Where is Travis? Travis is not there. Just give me a second here. Travis needs to, okay, you are here. All right, so be quick on the draw for me, please, Travis. Once I call people, it's my way of making sure everybody is paying attention. So please make sure you're responding quickly. Okay, let's keep going here. So we've solved that one, and turns out that there's only one solution for this, and that was where x is equal to 1. And again, you can always put that 1 back into the function and see if it works, all right? See if it works. Okay, Travis, I see what you're saying. Okay, now let's get to a more challenging question. Let's step up our game. Let's sort of, put on the well, anyway, let's get to this question. We did something similar like this before, but let's tackle this one. The volume of a rectangular box is multiplied by a polynomial expression. So we see what the polynomial expression is: 6x cubed minus 25x squared plus 32x minus 12. And what is the factor of the expression? Okay. If each factor of the expression represents one of the dimensions of the box, what's the applicable domain of the function? And I'll explain all of that to you in a minute. Then later they say the volume is required to be 100 centimeters cubed, determine the resulting dimensions of the box. Okay, so here is our volume function. V of x is 6x cubed. It's a cubic function. And you would expect it to be cubic, because if you're going to get the volume of a rectangular prism, you're going to take length, width, and height. That's how you get volume. All right. So where do we start? The second part of this, or the first part of this, says factor this expression. So remind me now, those steps in factoring. Where do we start with this factoring? What's the first thing that we need to do if we're trying to factor? in a number into the x as a factor of negative 12. Thank you, Omar. Can you give us an idea what you would choose? What number would you try first? That's a good start, by the way. What number would you like to try first? Give me some number which is a factor of negative 12. Minus 6. Wow. Okay. All right. You want to go up to the 6 right away. You know what, Omar? We'll take it. I wouldn't have done minus 6, but if that's what you want to do, that's what we'll do. So Omar says, let's try out minus 6. So we'll do that. Thank you, Omar, by the way. Thank you for participating. So I'm going to go V, and that choice is an okay choice because minus 6 is a factor of minus 12. So it's a legitimate choice. It's totally legit. So let's see how that works out. So 6 minus 6, I'm going to go for my calculator in a minute because I don't know how to raise 6 to the minus 6 to the power of 3. But we will do that in a minute. 25 minus 6 squared plus 32 times minus 6 minus 12. Okay? All right. I'm going to have to grab my calculator here, folks. Omar has really stretched me here. I can't do that in my head. So 6 times minus 6 to the power of 3 is, whoa, minus 1296. Okay? And then 25 times that. So that's 36 times minus 25. So minus 25, oops, sorry. Minus 25 times 36 should be minus 900. I'm doing it this way because Omar wanted to try this out, and that's okay. That's fine. 32 times 6, 32 times 6, or minus 6 anyway, is minus 192. This doesn't look like it's going to work out to me. And then minus 12. Okay, so Omar, this one didn't work. Not that it's not a legitimate step to take, but this one did not work. Let me just discuss why it didn't work, by the way. It didn't work because what we wanted to get from that by putting in that minus 6 was what? What number would have made this work? Before I go from Omar to somebody else, let me just ask you that one last question, Omar. What number are we trying to get when we put the minus 6 in? If the minus 6 would have been the number to use, and if it worked out well, then what result would we have got? This is not going to give us the result we want, but what result did we want to get for this to work? Omar, back over to you. Right? What would have made this work out for us? 0. Perfect. That is certainly not 0. That is absolutely not 0. So I'm going to say that this one is, I don't say it's a fail. I'll just say that it just didn't work. Okay? So I'm going to erase all of this here. And then I'm going to try a different number. Anybody wants to recommend a number that they think might work? Right? I'll take another suggestion from anybody. I'm not asking anybody in particular. But what number do you think we ought to try next? People are saying 2. Some of you probably tried it already. I'm going to suggest that some of you probably tried it already. Anyway, we'll go with 2, see what happens with 2. Just getting all this stuff out of the way here. And we're just going to take that out and put V of positive. You meant positive 2, right? Some people are saying 3 as well. I'm going to put positive 2 in there. So let's see how this works now. So 6, 2 cubed, I might be able to do some of this in my head, minus 25 times 2 squared plus 32 times 2 minus 12. Okay. So let's see now. That's 8 6s 48. That's 4, that's minus 100. That's plus 64 and minus 12. So let me just think about this for a second now. That's 64 plus that. That looks like we hit that one right. Travis is suggesting 3. Travis, maybe 3 is also going to work, but it looks to me as if the 2 does work. So I guess plus and minus 1 probably wouldn't have worked, which is why some of you probably never even suggested that. But it looks to me like 3 does work. Sorry, not 3. 2 does work. Just double checking my math here. Minus 112. Yeah, that does work. So here's what we now know. So that means that x minus 2 is a factor. And we're going to have to go through the synthetic division one more time. So I'm going to say, same thing we did the last time. Put the -2 on the side. I'm going to predict that's going to be 0 over here. Then there's a 6 here. There's a -25. There is a 32. And there is a -12. Okay. 6 minus 25 plus 32. Okay, good. Bring down the 6. -2 times 6 is -12. -25 plus 12 is -13. This would be 26. 32 minus 26 is 6. And that's -12. Okay, so here's what we have. We have x minus 2. We have 6x squared minus 13x plus 6. This is our v of x formula. But of course, we have to factor again. So I'm going to put my x in, my famous magic x in. Maybe you don't like the magic x, that's fine. I'm going to put a, what's that, 36 here. And I'm going to put a -13 here. And I'm thinking, what numbers can I use now that will add up to give me -13 and multiply to give me 36? And I'm thinking 9 and 4. Anybody with me on that? Or -9 and -4, I should say. Are you with me on -9 and -4? Does that sound about right to you? -9, -4? Yes? No? Don't like that? I think so. -9, -4. Okay. Thank you, Karis. Thank you, Noah. At least 2 people are in my corner on that one. I'm going to divide this now by 6. Why 6? Because that's the lead coefficient of the quadratic. Then I'm going to reduce this down. Right? I'm going to reduce this down by dividing both of these by 3. So that would be -3 over 2. Reduce this down, dividing both by 2. So that's -2 over 3. I think I did that right. So you think the method is easier than decomposition? Well, I mean, that's my opinion, but we're all entitled to our opinions. Seems so complicated. Well, then don't use it. No, that's fine. I really have no objection to you using decomposition whatsoever. And I keep using the analogy, I use it all the time when I'm teaching math, that if we're both heading for the Pickering Town Center and you decide to go on the 401 and I decide to go on Highway 2, if we both end up at the Pickering Town Center, then it doesn't really matter. As long as, how do you use the X method again? I tell you what I'm going to do, Kayla. I'm going to post a video. There's a person on YouTube that does the Magic X, I think, very well. I'm going to put the answer down here again. I'm going to go through it one more time, but I'm going to put a video in the calendar for today's calendar, and I'm going to ask you to watch that. But I'm going to go over it one more time again. I take the first number. Let me point to it as I'm doing it. We change it back to black, by the way. So I take the first number that I'm pointing to, which is the 6, the lead coefficient, multiply it by the last constant, which is 6. That's 36. That goes right here. Then I put the middle number at the bottom, the -13. And then I try to find the 2 numbers that will multiply to give me the product and add up to give me the sum. You do the same thing, by the way, Kayla, when you're doing decomposition. Right, Noah? You still have to do that same first step where you have to multiply those 2 and then get the product and sum. Is that true? Yes, good. The only difference is at this point where we part company is that what I do is I now divide, Kayla, the -9 and the -4 by whatever the first number is here, which in this case is 6. So I put the -9 over 6 and -4 over 6, and I reduce it down. You know, like you reduce any other fraction down. And then I'm now ready to factor, because my factors would be the bottom number times x plus or minus the top number, so 2x minus 3. Same thing here, 3x minus 2. Okay? And I see we're coming up to the break, but we're not quite there yet. And then, of course, we had the x minus 2 before. And that's my v of x function fully factored. So Kayla, does that help a little bit for you to see how that method works? And I put the video there, as I said. Kayla, does that help a little bit for the Magic X method? I'll definitely put that in there for you. Okay, excuse me. You're welcome. So here's my V of X formula. That's now factored. It started off being this, cubic function. I've factored the expression. That's done. Now it asks me another question. I'm going to give you a break in 3 minutes. If each factor of the expression represents one of the dimensions of the box, what's the applicable domain of the function? Interesting. So if we consider that these are length, width, and height of this function, what restrictions do we have to put on each of these? So let's say this is the length. No particular reason why I'm calling this the length. Let's say this is the width. Let's say this is the height. If you wanted to put a different one as the height, a different one as the width, doesn't really matter. Those are the 3 dimensions. That's the important thing. So here's the thing about the domain. Domain is, what are my possible x values? Can x be anything? The answer is no. Can anybody think of a reason why x cannot be any number you like? Normally we say that for polynomials, the domain is unrestricted, but this time it's not. Yes, Jeremiah. Go ahead. Mm-hmm. Mm-hmm. That is true, but I'm going to go further than that. Can any of these dimensions be negative? Can length, width, or height be negative? Is that possible at all? And answer to that question is no, it can't. So what does that mean? It means that we have to put a restriction on the domain. We have to now say 3 different what are called inequalities. X minus 2 must be greater than, not even equal to, but greater than 0. Jeremiah's observation is correct. Can't be 0, but it has to be more than just not 0. It has to be positive. The 2x minus 3 must also be greater than 0, and the 3x minus 2 must also be greater than 0. Let's put a line here to separate all of that. So those are 3 conditions that we have to meet. Now, there's only one condition that this really honestly boils down to. First of all, let me rephrase these inequalities. Since x minus 2 is greater than 0, I'm going to put that minus 2 on the other side and say that x must be greater than 2, that x must be greater than 3 over 2. I'm just doing a little, moving the 3 over and then dividing by 2, and that x must be greater than 2 over 3. Those are 3 conditions that we have to satisfy. Omar says no to something. What is he saying no to? What is the question, Omar? What is it that you're not sure about? Mm-hmm. Yeah, good, excellent. So we're going to set conditions on this. Okay, so it's 11:15. We're going to come back at 11:20 and talk about how this is going to impact this calculation. Okay, so take your 5-minute break, and we're going to come back at 11:20. I'm actually going to take us back to where we were last, which is that we were saying that there were 3. Can I move this out of the way? No, I can't. That's too bad. It's kind of in the way down here. Anyway, that there were 3 conditions that we had to satisfy, that x had to be greater than 2, x had to be greater than 3.5. Well, what is this thing here? I need to get rid of that. Okay, let me get rid of this as well. Okay, let me just put this last one back. Over 3. But I want you to think about what these 3 conditions really boil down to. Is there one condition that would make me meet all 3 of these conditions? So if I met that one condition, then I'm good. Right? Do I really need 3 separate conditions? I need to be greater than 2. also need to be greater than 3.5. Sorry, 1.5, 3 over 2. So that's 1.5. And I need to be greater than 2 over 3. What does have to be greater than those numbers, really? Great question, really. And I'm glad you asked that. I'm glad you asked that. Harish, thank you very much. I'm going to come back to that in a minute. These three things really represent the length, width, and height of the, what is this thing that we're looking at again? Let me go back and look at this here. This is for a rectangular box, okay? So if it's a length, a width, and a height, really, wouldn't it make sense that each of those things, the length, we factored it, so we know that those factors represent length, width, and height. Would it make sense that every one of them had to be positive? You can't have a negative length. You see what I'm saying, really? Does that make sense? Okay, so we took each one of them and made them greater than, not even equal to 0, because Jeremiah made the point earlier on that if any one of them was 0, that would be a problem, because the zero product law would then tell us that the whole volume would become 0. But even beyond that, we're saying not only can it not be 0, it has to be positive, right? X minus 2 has to be positive. 2x minus 3 has to be positive. 3x minus 2 has to be positive. Another way of saying something is positive is to make it greater than 0. Right? Because once you fall below 0, you're now negative. So really, that's what we're saying is the reason why we're setting each of these things to be greater than 0. So greater than 0, great, perfect. Greater than 0 makes it positive. Now I was asking the question, and so you answered the question already. If I have these three, I have to meet all conditions. I can't just meet one condition. I have to meet all three conditions. I have to be greater than 2, greater than 3 over 2, and greater than 2 over 3. Well, it turns out that if I just made x greater than 2, then that would make everybody else happy, right? So what I'm saying is this. Greater than 2, which is the first one, is going to take care of x being greater. So this is the one that I'm going to be focusing on. That's the one that really matters. As long as I'm greater than 2, I'm going to be greater than 3 over 2, and I'm going to be greater than 2 over 3. I've satisfied all three conditions by just satisfying one condition. Okay, hopefully that makes sense to everybody. Let me get rid of this. Let me put myself back to black here. Back to black. Come on, back to black. There we go. All right. So we're saying that that thing I just circled, x being greater than 2, is the most important condition that I must meet. Okay. Anything less than 2, right? Not even equal to 2. Let's see. But 2 is greater than 2 over 3. Exactly, Noah. Exactly. So as long as I'm greater than 2, then I will be greater than 2 over 3 as well. So I don't need to satisfy this one individually. If I satisfy, because remember what I'm saying, no, I'm saying you have to satisfy all three. If you only satisfied greater than 3 over 2 and greater than 2 over 3, but you are less than 2, then you haven't satisfied the third condition. So I'm saying you're satisfying x being greater than 2, right, will make the other two guys still happy. It's the overlap, is what I'm saying. Do you see what I'm saying, Noah? I just have to satisfy that one, and I'm satisfying all three. So let's pick a number. Let's just take a number. Let me give you an example. Let's take a number like, for instance, this is the equivalent of 1.5, right? That's same thing as 1.5. It's a very ugly looking 1.5. But anyway, 1.5. This is approximately 0.6, 0.7. Let's take a number, arbitrary number. Don't understand? That's okay. Let me do it this way. I'm going to put a number line on here, Noah, and let's see if this helps you out, right? So let's put 0 here. Let's call that 1. Let's call this 2. Let's call this 3. You're welcome. So here's what we had from the previous page. Let me remind you, right? We had these three things on the previous page when we factored it. X minus 2, 2x minus 3, 3x minus 2. Those were the three factors that we had for the v of x. I'm going to write that down on this page. So my v of x is equal to x minus 2, 3x minus 2, and 2x minus 3. So we factored it. Those are factors. We're good. I want my volume to be 100. What would you suggest I do to figure out what value of x is going to make that happen? Because that's what we're trying to figure out. That's what this question says. Let me take you back to the question. Right? Question says the volume is required to be 100. Determine the resulting dimensions of the box. I guess that's what you're asking. So how are we going to figure out what dimensions to use to make this 100 centimeters cubed? All right, I'm looking for some suggestions here, folks. Right? What would you recommend? What happened to my equation? What? Oh, it's that far down. Okay, there it is. Trial and error, you're thinking. Trial and error, how do I set it up, though? What's the setup? How do I start even setting it up? What do you think, Harish? Where does 100 go, is my question. Do I put 100 as the x or as something else? Where does the 100 go? 100 is for the v. Thank you, Karis. Thank you, Harish. So that's exactly what we're going to do. So I'm going to say that 100 is equal to x minus 2, 3x minus 2, and 2x minus 3. So here's my question for you. 100 place of the f of v of x. Thank you, Harish. Good. Here's my question for you now. You said trial and error, and I agree. Where do we start? What numbers do you think we should start to test out? And some of you are going to think, why don't I multiply it all or set it equal to 0 and all that? So I'm not going to do that at all. I'm trying to get 100, right? I'm trying to get 100. What numbers do you think I should test out? What's the first number that you would try out to put into this function? All right? What do you suggest? Give me some suggestions. What's the first thing you should think I should put in for my x to get this 100? Anybody? Can anybody suggest a number that's going to make sense for me to try as my x value? Because we need to try different values of x. I agree. But, and Harish said trial and error. Where do we start, though? What first value should we try? Nobody has a suggestion to that? Should I try plus and minus 1? Does plus and minus 1 make sense? Okay, why not plus and minus 1, though? What's wrong with plus and minus 1? Right, we normally try plus and minus 1 first. There's a very good reason why we shouldn't. It's too low. It does not fit the domain of this function. That's the point. That's exactly the point. Our x has to be greater than 2. We're not even going to try 2 because we said that x had to be greater than 2. Right? So the first number we should be thinking of is 3. And I see somebody there saying 4. Harish is saying 4. Let's try 3 first and see how that works out. And it's actually easier if it's in factored form. So I'm not going to multiply it all out and put it in. No, I'm not going to do that. I'm going to go ahead and try the 3 in this function and see what we get. So it's going to be 3 minus 2. 3 times 3 minus 2. And 2 times 3 minus 3. Let's see if this works. So this is 1 multiplied by, that's 9 minus 2 is 7. Multiplied by 6 minus 3 is 3. That's not going to give us 100. So even though it's a legitimate choice to use 3, 3 doesn't work. Harish has been telling us to try 4. So that's what I'm going to do now. I'm going to go ahead and instead of putting in 3, I'm going to put in 4. So let's put in 4 here. Oh, sorry, I don't know why I took that out. Let's put that back. Let's put that 3 back in there. Come on, we're supposed to undo. Undo again. X, okay. So let's put 4 instead. So I'm going to erase this, erase that, erase this, and of course this down here is going to change once I do that. So here's a bit of a shortcut thing for you where you're saying, I don't really have to go ahead and multiply it out, set it equal to 0 and all of that. Let's just put it in factored form. Right? So we're in factored form. So let's put the 4 here. Let's put 3 times 4 here. And let's put 2 times 4 here and see if this works. That's going to give me 2. That's going to give me 12 minus 2 is 10. And that's going to give me 8 minus 3 is 5. And you know what, folks? All past Ava is saying, okay, Ava. That's giving us 10 times 2 times 5, which is in fact 100. So there's our answer. Sometimes you don't want to overdo it and spend a lot of energy doing stuff that's not necessary, right? If 4 works, then those are your dimensions right there, right? The x minus 2, the 3x minus 2, the 2x minus 3 are going to give you these numbers right here. So here are my dimensions. The dimensions of this box that are going to give me 100. Right? I know I didn't have to try plus and minus 1. I know I didn't have to try plus and minus 2 because my domain is that x has to be greater than 2. So the dimensions are 2 is it centimeters? I think it was centimeters, or is it meters? Just give me a second here to check. Rectangular box model with fractional expression depends on centimeters cubed. Okay, so centimeters. So dimensions are 2 centimeters by 10 centimeters by 5 centimeters. Okay, so much easier. It doesn't work. If 4 didn't work, then we could, yes, you'd have to keep going, unfortunately, really, yes. Right, again, as long as you keep numbers that are bigger than 2, then you keep going. Now, the other thing you want to look at, let me go back to the question a second here, is this last number here again, which is the 12. You still want to stick with factors of the constant as well when you're trying out different numbers, okay? So that's what we're doing. We're just making our lives a little easier by looking at the most efficient way of carrying this, going through this question.